Okay, it's Mr. J. Today we're looking at different types of fractions and how you can convert them and maybe why you'd ever want to bother converting them, besides the fact that somebody's telling you that you have to convert them. So in our last fractions video, we looked at the three types. So the type of fraction that you're probably used to is a proper fraction, okay? And those are all of our fractions that exist in between 0 and 1. So that's like every normal fraction, okay? It's less than a whole, right? We talked about that last time. So a half is, halfway to being full, right? 999 out of 1,000, is, right before being full. It's still not full, but it's still proper, okay? So any fraction where the numerator is smaller than the denominator is proper, okay? So normal, okay? The two we're gonna look at this week are improper and our mixed numbers, okay? I'm not really sure. I always kind of wonder why they're called mixed numbers instead of mixed fractions, but I don't know, whatever. Okay, and it's pretty sort of easy to tell the difference. An improper fraction is going to be the opposite of proper, okay? So whereas a proper fraction is numerator smaller than the denominator, an improper fraction just breaks all the rules. Whereas it's hat backwards, it sits in a chair backwards, it does everything backwards, okay? Talks back, it's rude to the teacher. Oh man. Improper fractions are any fraction where, let's put, I don't know, 7 on the top and 2 on the bottom. That's not how fractions work, okay? It's improper, man. All right? And that's all an improper fraction means. And improper fractions are always bigger than 1, okay? Which makes sense, because if your numerator is bigger than your denominator, it means you have more than what you need to have a whole, right? For a proper fraction, like 1/2 or 1/3 or whatever, or 999 of 1,000, you're not full. It takes 2 to be full. I've only got 1. I'm not full. Okay, it takes 1,000 to be full. I've only got 999. I'm not full. Okay, those are all less than whole. A improper fraction is always greater than a whole. It's always more than 1, right? 7 out of 2. 7 halves, that's a lot of halves, right? If I need 2 halves to have a whole, I've got 7, I'm big. I'm a lot bigger than a whole, okay? Mixed numbers, on the other hand, they are mixed. They're a combination, all right? So they have a whole number, like 2 attached, and then they've got a fraction attached, like 4/5, okay? And some of you at home might be thinking, yo, Jay, is there improper mixed fractions where you have a whole number and then you have an improper fraction beside the whole number? And the answer is, I just wrote one, so I guess kind of yes. But no, okay, you cannot, this is a big no-no. If you do this, a black hole will open up and Einstein will come out and he'll pull you in and you will live forever just spinning through space wishing you were not. So do not do that, okay? To mix those doesn't make any sense. It doesn't make any sense, right? If you're going to build the whole numbers, then you get as many whole numbers as you can. So let's just look at this fake fraction that doesn't exist. Hold on. Oh my God, I thought Einstein was behind me for a second there. Okay, I'm okay. They let me do this because I'm a math teacher. Yeah, so 2 and 7 halves, right? What would that actually, let's draw it out. What would that actually look like? 2 and 7 halves. So here is my two holes. So let's just fill those in. Okay, and then I've got 7 halves. So let's make some halves. There's my halves, okay? And I need, how many? I need 7 halves. So here's 1 half. Here's 2 halves. Here's 3. Here's 4. Here's 5. Here's 6. And there's my final half. Okay, so 2 and 7 halves doesn't make sense to say, right? If I was phoning up like a shipping company because I'm getting something shipped to my factory, I wouldn't be like, yo, send me 2 and 7 halves of a crate. They'd be like, what? 7 halves, right? No, I would say I need 1 crate, 2 crate, 3 crates, 4 crates, 5 crates, and then a half, right? There's my half crate. So 2 and 7 halves doesn't make any sense. It would make a lot more sense to say 5 and 1 half, right? Like that makes sense. Okay, so that's, I mean, kind of we're kind of done. I mean, that's kind of what we need to do. We need to look at how do you convert an improper fraction into a mixed number, and how do you convert a mixed number into an improper fraction. I mean, that's basically what we just did right here, okay? But let's do it just to make sure we've got it covered. So we're going to do both of those. We'll start with improper to mixed. which again, I mean, kind of what we just did, but let's do it. So let's take an improper fraction. Let's take, oh, I don't know, let's take 6/3. Okay, let's take 6/3, which is an improper fraction because the numerator is bigger than the denominator. It's way more than 1 whole. I mean, you can kind of probably guess already how much. You know what? Let's do 7/3. Just let's make it a little harder. I got a good feeling about you guys. So let's do 7/3 instead. So how would I convert that into a mixed number where I've got a mystery whole number and then my mystery leftover fractions? Okay, that's what we're trying to do. We're trying to turn it into mixed. So let's draw it out. Okay, I mean, math should be visual. You know, people who say they don't want to draw the math, they don't want to, you know, oh, back in my day when I went to school, we just worked with calculators at our okay, whatever, who cares? Okay, they're doing the visualization in their head, and they've become so good at it over time that they are not sort of even conscious of it. Okay, you always got to show your math. You gotta think about it, what it looks like. Okay, so 7/3. What's that gonna look like? Okay, so I'm gonna build a box, and I'm going to put it into thirds. Not just because I love thirds, but because that's what I'm being told to do, okay? It's in thirds, so my holes need to be in thirds, okay? And you can split them any way you want. I'm going to split them vertically this time. So there's a hole, and I've split it into 3 parts, okay? And now I'm going to start filling it. So how many thirds do I need? I need 7 of them. So let's fill one in. And let's fill the second one in. And let's fill the third one in. And I've run into a problem. I'm trying to fill up 7/3. I've filled up 3/3, but I don't have any more room. And that tells me I need another hole. I'm already over 1 hole. I split it into thirds again because it's thirds. I don't have a choice. I mean, I could split it into eighths or 37ths if I want, but that's not what the question is telling me to do. So let's start filling it again. Okay, and I'm up to 1/3, 2/3, 3/3, 4/3, 5/3, 6/3, and I need more. I need another third. So I build another hole. You don't just build the third, okay? I got to build another hole, and I got to fill in just 1 more third because that'll give me my 7th third. Okay, and there we go. So 7 thirds, or 7 out of 3, written as a mixed number, would be 2 holes. Okay, there's my whole numbers. Why 2? Because I filled 1 hole. I filled a second hole, but I did not fill a third. So I can't say 3. I mean, I could, but I'd be wrong. Okay, and then I've got how much more? I've still got another third to go. Okay, so that's it. I mean, that's how you convert a improper fraction into a mixed number, all right? And, you know, improper fractions don't exist a lot in real life. You don't, you know, use them in real life. You wouldn't phone someone up and be like, hey, will you know, I need a, whatever, I need that part for the auto shop I run. Okay, how many parts do you need? I need 7/3 parts. What? Wait, who is this calling me, right? Like 7, no. You'd say I need 2 1/3 boxes of the part, or whatever, okay? So the improper fraction is not something you see a lot in life. You're much more likely to see that mixed number, all right? Guess what? As somebody who likes math and likes teaching math, these are the same, okay? Some teachers may tell you you must convert into a mixed number at all costs or else, and I mean, okay, fine. But these are exactly the same thing. Here's 7/3, here's 2 1/3, they are the same, okay? They are exactly the same number, they are exactly the same value, they have the same amount. If someone wanted to trade you 7/3 bars of gold for 2 1/3 bars of gold, I mean, it's a waste of time. They're the same. There's no value in either one more than the other, okay? However, you know, it is part of the math teacher's job to make sure that you can do both, okay? But I just want to make that clear. So there you go. There's improper to mixed. Now let's do the other way. So let's take a mixed number and turn it into an improper fraction. Let me just flip this page over. Oh man, you can see all that. No, I feel like I'm killing trees here. Okay, let's do a mixed number to an improper fraction. So let's take, I don't know, let's take 3 and let's go with a good old half. Let's go 3 1/2, and we want to turn that into an improper fraction where we got a big honking number over a smaller number, right? Because that's what an improper fraction is. It's more, there's more on the top than there is on the bottom, right? We have more than the whole. So how am I going to do that? I'm going to do the same old thing. I'm going to draw out my 3.5. So I'm going to need, well, let's stop at 3. Let's see what I need. Okay, and what am I going to split my boxes up into? I'm going to split them up into halves because that's what it tells me. So each box is going to have 2 parts. Okay, if it was 1 out of 7, I would need to make 7 parts in each of my boxes. Okay, I just go with the rules. So let's start filling up those boxes. So how many boxes do I fill? Well, I need to fill 3 boxes. Let's use red. So I'm filling 3 holes this time because it's a big old 3. It's not a little fraction where the number's only half the size. Get out of here. Holes. All right. So there's my, and then I've run into my problem. I don't have enough boxes, so I need another box. That's all. Phew. I love when problems are easy to fix. And again, I split it into halves because that's what the questions told me to do. And this time, I'm not filling in the whole box. I'm only filling in half because it was 3.5. Okay. So now that I'm done, how many halves did I fill? Let's take a look. So I know it's still halves because my holes are split into halves, right? Before it was thirds, and my boxes were split into thirds. But now it's halves, so my boxes are split into halves. How many halves did I fill? Let's find out. I filled 1 half, 2 halves, 3 halves, 4 halves, 5 halves, 6 halves, 7 halves. So my answer is 7 halves. Okay? So 3.5 is the mixed number version of this story. 7 halves is the improper fraction. Again, both are the same value. Both are worth the same. Both are correct. And in real life, you pretty much never see 7 halves. You see 3.5, right? But again, it's a math teacher's job to make sure that you can convert both ways. Okay? And what I like about my model, there's other models to do this. This is just one. What I like about my model is it's the same model both ways. You just draw it out. You count up things. If you can draw and you can count, then you're jamming. All right? Can we do one more? Let's do a harder one. Let's convert 2 and 4/7. That's kind of a weird fraction. 2 and 4/7, and let's convert that into an improper fraction. So here we go. So again, I know I need 2 holes. And I mean, since I've been doing this a while, I know I'm going to need more than 2 holes. I know I'm going to need at least a 3rd hole because I got 2 and then some more. Okay, and how much am I going to split them into 7? Ooh, I made it hard on myself. 1, 2, 3, 4, 5, 6. Whew! Okay, so I split out into 7s. 1, 2, 3, 4, 5, 6. Pro tip, you always just need to draw one less line, right? Because you're already starting with 1 box. 1, 2, 3, 4, 5. Okay, and if you're not sure, just count them up. Okay, but and if you make a mistake, let's pretend I did 6. 1, 2, 3. So let's pretend I counted 1, 2, 3, 4, 5, 6. Oh, I gotta rip up my whole page. No, you just draw another little box on the side. Okay, that's what I like about these boxes. Okay, but this I don't want right now. So 2 and 4/7. So all this is a hole. All this is a hole because I was told 2 holes, right? 2 holes, and then 4 of these. So now I gotta color a little more carefully. 1, 2, 3, 4. Whew! Heart attack, baby. So how many 7ths in total did I end up having? 7, 14, right? Because there's 7 and another 7 in the holes. So 14, 15, 16, 17, 18. Boyakasha. So 2 and 4/7 converted into an improper fraction is 18/7. All right. So the model works. It'll always work. It's easy to draw out. It's pretty quick to do. It's not too complicated. If you can count, I think you can do this method. So good luck converting those fractions and catching the flippity flop.